Concrete examples are staples in education. Through them, we help students to build models of concepts and procedures. But examples don't always work as expected. In this video, we will examine the shortcomings of examples and how to overcome these challenges. Here's a common situation that many teachers have experienced. My students learned about the structure of the heart. The lesson went great. I gave them some diagnostics to check their understanding. By the end of the class, I felt confident that they knew the structure of the heart and could label a schematic of the heart. But then later on a test day, several students could not accurately label a heart. I was upset. Didn't my students bother to study? When I asked these students what happened, they complained that the image that I used on the test was too complicated. Sure enough, when I asked them to label the original image that I used in class, they could do it. But why should this be? The practice image and the test image were almost identical. There are just more errors on the test pictures. How could that be a problem? The problem was that my students who had problems on this test had memorized a specific case. They had not created an accurate mental model of the heart, and so they did not understand the structure of the heart and could not recognize the structure if it deviated from their memorized case. So how can this be avoided? To understand what went wrong, I needed to reflect on how we build models in real-life situations. To illustrate how this is done, let me introduce you to my best buddy. This is Loki. He isn't facing you and you can't see all of him, but I bet you can tell with confidence that Loki is a dog. Which is funny because I would bet that no one has even defined what a dog is to you. And dogs are the most morphologically diverse species on the planet because they are the oldest domesticated animal, and we humans have been selectively breeding them for a wide variety of traits all this time. So if dogs are so diverse, how can we so readily recognize a dog? And how can most of us tell a dog from a wolf, even though they can look very similar? The answer is that our brains have been given so many diverse examples of dogs that we have an extremely solid mental model of what is and what is not a dog. Due to repeated exposure to diverse examples, we know what a dog looks like, sounds like, and behaves like. We know a dog, no matter the breed, because a lifetime of exposure to a diversity of examples has allowed our brains to build a model of a dog based on the common characteristics from a wide diversity of identified samples. So how can we replace this lifetime of data exposure in the classroom when we have months and not years to work with? In order to replicate this model building process in the classroom, it is important that examples be as diversified as possible. So if I want students to build a model of the heart, they must experience a wide diversity of models, 2D schematics, 3D models, computer animations, preserved specimens. The more the merrier. The more different they are, the better. However, I can never provide enough examples in the time I have to cover the concept. So I need to use a strategy to encourage my students to actively deconstruct the models for common features. Ironically, an effective strategy to do this is to break away from the core model I'm aiming for and have my students engage in exercises that demand they employ skills in comparing and contrasting. So for example, I can give students the model of a variety of non-mammalian hearts and ask them to observe the similarities and differences. Based on their observations, they can then infer how the heart design is likely to impact blood pressure and oxygen content. Such exercises create a demand on them to deconstruct and analyze the examples. So let's look at a sample task on how we can use comparing and contrasting to improve students' mental models and at the same time target their higher order thinking skills. The sample we will examine is from the Ecology Unit for Grade 9 Academic Science. In the Ecology Unit, students are expected to gain an understanding of ecosystems and biomes. Traditionally, they are asked to read about or research an ecosystem to help them gain a deeper understanding of these concepts. This year, we use HHMI's BioViewer app to allow students to gain a deeper understanding of biomes. This app allows students to download data from biomes across the planet. In addition, the biome has a compare and contrast feature. Using the compare and contrast feature, students can download the data for two locations of their choice in a side-by-side panel that makes it easier for comparisons between the information. Students were given an assignment to compare and contrast any two locations from different biomes and to create a poster display of their analysis. By shifting away from students passively reading and hearing about a single biome and moving them towards actively comparing and contrasting different biomes, we were able to facilitate students building better models of ecosystems and biomes. However, the new design also had additional benefits because it gave students experience in more difficult literacy skills and key inquiry skills. Links to my files associated with this task are in the video description below. If you're a science teacher and this sample activity interests you, feel free to download them. And I would like to give a really heartfelt thank you to all the folks at HHMI Biointeractive. They produce an amazing wealth of first-rate resources for biology classrooms completely free of charge. They are simply amazing. If you are an educator and this subject matter interests you, please consider subscribing to this channel. I will do my best to make videos on educational topics at a reasonable pace. Please remember that I am a full-time teacher, so don't expect frequent or high-quality videos. My sincere hope is that my videos are useful to others and helps me to consolidate and reflect on my practice. And finally, if you are a classroom teacher, good luck to you on your journey. We are all in this together.